My suitcase build, if you've seen that video, uses three of the Routemaster PCBs, three of these, and they're connected together in parallel, or they were, and then I changed my mind. So what I found was the wall warts, the plug-in transformers that go in your socket in the wall, I think they lie, and certainly on modular ModWiggler, a lot of people comment and say that the output rating of the transformer is not accurate, it's not true. And I think there's some truth in that, because I put 3 PCBs on a 3 amp wall wart and it struggled. It didn't work. It was powering up, everything worked fine. I don't need that. Everything worked absolutely fine. But on powering up, some of the digital modules, in particular clouds, seemed to struggle. They wouldn't just start up straight away, excuse me, and that's because the capacitors filling up with juice, these big capacitors here. So you need to power cycle it, so you need to turn it off and turn it back on again. And I didn't really want that. I wanted it just to go, you know, just to boot up. So what I did in the end is I split one of the boards into a separate power supply. So I put a separate wall wart onto it. And that helped, because then, that's a really bad start. We're going to have a bad day, aren't we? Because then, then I had enough juice. So what I ended up with is about a 1.6 amp transformer on one of the boards, and then a 2 amp transformer on the other 2 boards, or maybe 3 amp actually. Now, Rick says if you load it, if the load is 3 amp, that's really pushing the voltage regulators. Probably a bit too much and a bit too hard. He does say what you need to do is put bigger heat sinks in. So in my other case, I do have bigger heat sinks on the voltage regulators. So the diodes, I think, yeah, they go down here. So there's 4 of them, and the band is marked on the PCB. So we've got a little line. So you need to make sure they go in the right way. And I believe this may be the rectifier that turns AC current into DC current. So this additional ground plane that Rick Holt's put in this board means that you need even more heat or even more time. I think, there we go, that's better. Fine. So, where do these go? These are quite easy to find because they're like an oval lozenge shape. I like to put the numbers the same way around because of OCD and all that. So apply that heat and leave it on for a bit. That doesn't look great, but it's fine. It says do the LEDs next. 1, 2, 3. Now I did have a bag with lots of different coloured LEDs, and I was going to be all like creative, and I was going to put the 5-volt LED as a different colour to the other ones, but I've lost the bag. I don't know where I've put it, so I can't do that. And if you're like me, you've probably forgotten, or you do forget, which leg of a diode is the cathode and anode, the anode being positive and the cathode being negative. I can never remember, but what I look for is on one side of it is a flat. I believe the flat is negative, so the short leg is negative, I believe. But the good news is, even if you don't know, there's a flat on the PCB. So if I put the flat of the LED against the flat of the PCB, and I will double check because I do make this mistake all the time, then I should be the right way around. I think the difficult bit about soldering isn't soldering, it's fixing a mistake. That's a bit harder. Actually, soldering's pretty straightforward, isn't it? You know, apply heat, apply solder, don't wiggle it, done. Yes, it's a plus 5 volts, 100 milliamp voltage regulator. That's the part. That's what we're doing. And these are also sensitive to positive and minus, polarity sensitive. So again, on the board, really clearly marked. the unit has a flat side, the PCB has a flat side, so it's as straightforward as that. And dear Mr. Holt, in his build instructions, suggests that you, to avoid a solder bridge on this, that you do either do the middle pin on its own, which is what I'm going to do. So we'll do the middle pin. A bit more solder on there, I think. And then wait, and then do the two outside pins, or vice versa. The reason being that if you heat up one of the pins and then go to the next pin, you heat that up, this has still got heat in it, and you're likely to get a solder bridge. So if you do them separately and then just wait, let it cool down, you're less likely to get a solder bridge. And it was a top 10. Now we're going to do electrolytic capacitors. These are the 10 UF and the 100 UF. Where's the 100 UF? I won't get them both out at the same time, just checking I've got them. They're the 10 UF. I haven't seemed to have got 100 UF out. I may have to search for them too. Or I did get them out and I've put them to one side because they were the wrong ones. 10 UF, let's do the 10 UF. It'll be fine. How many of these do we need? 10 UF. We need 2. So these are electrolytic capacitors, also known as cans, I think, or aluminium cans. They do have a positive and a negative, so we need to make sure we get these the right way around. And these are the 10 UF. Just going to double check that they are 10 UF. They're not in the wrong bag. They're 10 UF. I was watching another video the other day, and again, short leg cathode, long leg anode. So short leg is negative, long leg is positive, and also it's marked very clearly on these, which is the negative leg. And then on the board, just like before, the square pad is the positive, the round pad is the negative, and it's actually got a little positive sign next to it. So the positive rail, or the positive pad, is really clearly marked, which is ace. Thank you very much, Rick. Oh, I ain't got time, right? I ain't got time. I literally shoot these videos on my phone. I even edit them on my phone. That's shocking, isn't it? The only thing I will do is I will try, when we're doing the actual modular and making a racket with it, I will try and record the audio from the modular and sync it to the video, because mobile phone, microphones are not brilliant, are they? So 100 UF in there, 100 UF in there. So these are all negative going that way. Is the other one the same? Yeah, it is. So we should end up, when we lift the board up and look in a minute, we should end up with all the negatives pointing the same way. It says install and solder 2K multi-turn trimmers. Now these are important because when we hook it up to power, eventually, these are going to let us, with the multimeter, these are going to let us dial in the voltages correctly so that we get 12 volts positive, 12 volts negative, and a 5 volt. Yes, I had no idea what I wanted to do with modular. It was mainly about making an instrument. It was mainly about making something that had a function and spending time doing it in an enjoyable way, more than the music. Having said that, I really enjoy patching for larks, because it's good fun. Just good fun, isn't it? And I have a plan to make some videos about the actual Eurorack and using it. I don't really want to do what everyone else is doing. There are some amazing YouTubers that I love and watch all the time, and I love their content. Like, I really adore it. I've been patrons for some of them for some time. I've had to stop that because I'm broke. DivKid would be notable. DivKid makes some fantastic review videos, but not only does he review the module, he shows you how to use it, which is brilliant. Because if you're stupid like me, that it really helps. Install all power headers. Now this bit will be dull. This is the bit that I'm afraid, from a TV entertainment point of view, is going to be rubbish. We've got 12 of these to put on. There's 16 pins on each one. Now, other YouTubers would, of course, speedrun this and show you doing it differently. So on these, I don't know whether you can see there's a little arrow down there that says that pin is negative. And then on the PCB, we've got this big white line, so it's really obvious which is negative. So these are going to go like this. If I can get it in. There we go. They're going to go like that. Right. So that's how they're going to sit in there. And actually Rick, because he's a superstar, he's actually even put a little mark on the board where the cutout, the notch on the boxed power headers goes. So you would be hard pressed to mess this up, but mess it up you can. Probably the easiest way to mess it up is to just forget that you just put one in the wrong way around and then solder it. That would be a pain. So we're not going to do that. We're going to do it right today. We're going to take our time. We're going to double check and triple check and things like that. So yeah, this will be perhaps the dullest moment of YouTube history on the face of the planet, because 16 pins, all of these, that's going to take a while, isn't it? That's going to be a slow process. Now you could do a thing called drag soldering, and I have done drag soldering. And drag soldering is where you change the tip on your soldering iron to like a longer, flatter plate, and you heat up more than one pin at a time, and you literally drag the solder and drag the soldering iron across the pins, and it actually goes quite quick. And as I say, I have done drag soldering, but I'm not going to do that today because I want to make sure we've got no solder bridges. That's the main reason. Now the other problem with this is I need to flip it over and they're all going to fall out. So I need something to put over the top when I flip it over to hold them in position. Let's use that. And that means we can flip it over without them all falling out, hopefully. And we've got a problem already because that is sticking up higher on one side than the other side, which means we're going to end up with a load of wonky sockets. We don't want that. So I think we'll go for tape. Can we do tape? I think we can do tape. We'll do the tape thing. So what would help here is if I had something to raise this up a bit. And again, tape is really good for that because tape's got a big hole in the middle. I'll use this little pot instead. There we go. Let's raise that up. Pop those on. Do that all over again. So there's no Blue Peter, here's one I made earlier, is there? It's just a laborious long process of watching an idiot build this crap in real time. Is there a competition for like the worst YouTube channel ever? Can I win it? I think I'll be there. Got to be somewhere near, haven't I? And then what'll happen now? Because I've had to put them all back in again. I guarantee I've probably put one in the wrong way around. So I need to check. I need to double check, don't I? Calm myself down and definitely double check, triple check before we solder them. So we will take the time. We will do it right. Let's just double check. So first check, have we got the negative side down here? Yes, we have. So if I take one out, you can see the white line is there. Fantastic. Second check, notch, 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 notch. So all the notches are pointing the right way and they match with the PCB. So we know they're the right way around. I reckon we need about that much tape. What we'll probably end up doing is just soldering one pin on each leg, checking that they're flat and straight, and then soldering the rest. Let's see if we can do this with tape. This is always a fiddle, this. Oops. See? Always a fiddle. Ugh. And of course I've not made my tape long enough. But I do kind of want them to sit flat. it would annoy me if they're not. And of course, every time I put the tape on, it's pulling them, pulling them. What else could we do? Well, the other thing we could do is we could use something maybe that would step it up. That might do it. Let's do that instead. What we got? Is that long enough? No. Of course, we haven't got anything long enough. That's typical. What have we got? The problem is, you see, the capacitors are higher than that. So if I had something that just pads that out a bit, that would solve the problem, and it would be easier for us to solder. I've got some foam with that. Is that long enough? It's almost long enough. Let's try that. Will that help? It'll mostly help. We've got a couple that it's not going to help. And then, of course, it's going to fall off now, isn't it? I can't. There we go. There we go. It's like some Heath Robinson thing. But all I need to do is one pin. One pin. I just need one pin on each of them. That's all I need. One pin. So I am going to put on my stupid goggles for this because they're quite small. It's quite hard to see. And I don't really want to create a problem in the solder bridge and things like that. My soldering iron has gone to sleep, which is fine. Yeah, we'll do it real time. So now the problem is with my goggles on, I can't actually see the board at all unless I put my head under the camera. So that's not going to work. So let's not do that. Let's see if we can get one pin done on all of these, and then we can check and see if they're flat. That's the game now. Dooby-dooby-doo. Yeah, so I had a bit of a problem when I started trying to work out what I wanted, and that was okay. I kind of knew the basics of the power supply. So the way the power supply works is you've got a plus 12 rail, they call them a rail, but you've got a plus 12 side, and then a minus 12 volt side. Sorry, I should say volt. A plus, what was I saying? A plus 12 volt, a positive 12 volt side. That's horrible. And a minus 12 volt side. And then some modules, but not a lot these days, use a 5 volt supply as well. So they need a 5 volt supply. There aren't that many modules that do that now. And sometimes where a module needs 5 volts, they'll actually put a 5 volt converter or a 5 volt power transformer, regulator, voltage regulator in the actual module, which is really neat. Some power supplies just don't have a 5 volt power supply. You can also get a little plug-in thing that plugs into your bus board and then provides a 5 volt power supply. I think Dope make one of those, for example. So you can get that, and then you can have your 5 volt power supply if that's what you need. These boards do have an inbuilt onboard 5 volt power supply, which is lovely. So you have that luxury. Yeah, so you've got minus 12, plus 12, and then you've also got a 5 volt potentially if you need it. You don't, like I say, not a lot of modules need it. I have got a few. And of course, one of these has fallen out. There we go. Of course it has. That's a thing, isn't it? That's going to happen when you try and do this on camera. There we go. So now with my special foam thing and my fingers deftly holding everything, I think I can get it somewhere near. So now we can have a look and see if they're flat. Missed one. I've missed one. There we go. Have I missed one? Or is it not soldered properly? Or is it pulled out of the socket? Oh, it's pulling the pin out of the socket. That's great, isn't it? There you go. That's joyous. But with one pin in each of those, we can check that they're mostly flat. And they're kind of pulled over to one side a bit. So if I need to flatten them off a bit, if I just reheat, hold the socket, try not to touch the pin because the pin's really hot, I can just get them all settled back in because they have all pulled over to one side, as they would, of course. But it's worth taking the time in it, you know. Just making it nice. Just making it nice. hardly got any solder on that one. What was I thinking there? Oops. And of course I have caught the plastic with the soldering iron somehow. I've done that. It's working on the other side. That's strange. I've melted the soldering iron a bit. I must have touched one of the plugs by accident with the soldering iron. I don't know how I've done that because I was working on the other side. It's got some strain on that one. And I will go through and reflow these because they are moving around a little bit, which that's not ideal. It doesn't help that the pins seem to be loose in the box headers. So when it's sliding around, it's actually the pins that are sliding through the plastic, not, if that makes sense. Not had that before, don't know why. I've got a batch where they've not really got the tolerance, or I've melted the plastic too much, which is a thing that does happen. Ouch, that was hot. So what I can do now they're flat, I will put some more tape on just because they seem loose in the plastic. Yeah, so what I did with modular grid is I didn't do modular grid. I didn't use modular grid to plan out my system at all, really. What I did instead is I looked for a power supply that was capable with what I thought I might need, and then went from there. And when I started, I didn't plan a big case. I just planned a very small case. So it was 104 U. No, sorry, 104 HP. And just one 3U, so just one module height, and I'm glad I did that. And that was quite a good thing to do. Partly because what it meant was when I was ready to step up and get more modules, I just bought another little wooden case, and that was it really. It was as easy as that. And then that way my system grew with me. And all I did was just, because it was a new case, it just meant adding a new power supply to that case. Was it cheap? Yeah, it wasn't too bad. I mean, the first case I built myself, so that it's rough. It is rough. It's not pretty. Do you know what I mean? It's ugly, but I did my best. I have basic woodworking skills at best, so I built that out of plywood, and it's just a box. All it is, just a box, but it seems to work quite well. And then I just put a switch on it and a socket, wired it up to one of these, and that's the other reason why I've stayed with these power supplies, really, because actually they're quite organic. They can kind of grow with you, and they're also a linear power supply. And a linear power supply is supposed to be quieter, so you don't get as much interference. And to be fair, you never hear anything from these power supplies. They are silent. I have, however, had a problem with digital and analog modules, and this is not peculiar to just these bus boards. And I've done some research, and I still don't understand any of it. There's some fantastic people on Mobwiggler, which is a forum, who've given me lots of kind of information about why it happens and how to stop it, and I don't really understand like stuff. I suppose where I have understood a little bit more is I think you get a thing called crosstalk between digital and analog. It doesn't happen with every module. And the crosstalk happens, I think, because of what they call the zero reference, or we'd call it ground, but ground's not the right term for it, is zero reference. So zero reference in this case is this trace here. Can you see that trace there? That's the zero reference trace there. So some modules basically interfere with each other on the zero reference or the ground. shouldn't call it ground. It's zero reference. It's not ground because it doesn't go to ground. It doesn't go in the earth. I think the correct term is zero reference. But again, it's electricity. I don't really understand electricity. There you go. So basically, the issue is that they all share this common zero reference rail. And I believe that's where the interference happens between some of the modules. And when I had one power supply in one case, I did have that problem. It seemed to be the sample and hold module, which I don't really understand because that's analog. But anyway, the sample and hold module would cause the oscillator, an analog oscillator, to pulse, like you'd hear it. So every time the LED went on and off on the sample and hold module, the oscillator would kind of pulse audibly. You'd hear it. So that really annoyed me. And to be honest, it led to me not really using my analog oscillators much, which is a shame because they're amazing and they've got so much kind of richness of tone. They're quite harsh. Like if you just plug them straight into your sound card, they're really noisy. But quite like an analog oscillator. So that really annoyed me. So what I did in the new case, or the suitcase that I built, is I split the power supplies. So the analog power supply, one of these, is separate to the digital power supply. And now I've got very, very, very clean signal between the two. Right, I don't need the tape anymore because they're now properly stuck down. I'll get rid of that. And we just got to do this endless soldering. Now, because the ground planes are a bit of a pain, when I get to the ground planes, I'm going to use some flux. I say they're a bit of a pain because, as we've already established, Mr. Holt and Frequency Central have put in extra layer into this PCB. So the ground plane has got an extra layer to help with heat dissipation, I guess. I wonder if it would help with crosstalk between digital and analog modules. I'll be interested to find that out. Because I imagine it would. It would be very, very interesting. We'll have a play with that. So yeah, in the new case, I don't have a problem with analog and digital. The power is enough and it's supplying the modules with more than ample power because it's split onto 2 rails and then 1 rail. That's been amazing. So I'm really, really happy. The only problem I've got with the new case is when I've put it all together, where I've put the power socket, the power inlet, they're just barrel connections. Interestingly, Dope say don't use barrel connections, and I've heard it now from a few people, and if I was going to do it again, I probably wouldn't use barrel connections because they're just not really man enough for the job. That sounded sexist, didn't it? Not person enough for the job. In other words, they wear really quickly, I think, and they go loose. And I've got one of them has gone loose, and it means really to fix it, I'm probably going to have to take everything out to get to it because I don't think I have a socket that would work because of the wires and the wiring. I might be able to tighten it up just with some pliers, maybe. I'll try that. But other than that, new case is amazing. New case has been a revolution. I am chuffed with new case. So that's a -12 and a +12, 1 and 1. Then we've got, I think that's the 5-volt rail, and that's the ground, or is it the other way around? I can never remember. No, that's the 5-volt rail there. That's the 5-volt rail, and then these are all grounds. So that's those 3 in the centre are grounds. That's the 5-volt rail. So we'll do the 5-volt rail. We'll make sure we got that on using the same temperature and stuff. 5-volt rail should go fairly easy because it's not massively thick, is it? So if these 2 pins bridge that way, it wouldn't matter because that they do the same job. there's two of them just because of IDC connectors. IDC connectors were never really designed to carry ampage and stuff, particularly. They were designed to carry a signal, so very, very low current. So in Eurorack, they're all kind of doubled up mostly, and that just helps again with that resistance and heat build-up. Oh God, we're getting invaded by a cat again. No, you don't want to get burnt by a soldering iron. Really? Okay, I'm going to have to stop for a minute because I don't want to burn the cat. It would be bad to burn a cat. Burning cats is not a thing. So I'm going to take a break, give the cat some attention, and be back in a minute. It will be a bit more crowded, so I'm going to put it into continuity mode. That's one press there, and when I touch them, I get a short. So I should get a short between those two pins because they're connected, right? And I do, but I shouldn't get a short between one of those pins and one of those pins. And I don't. And the next one, 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 and the next one. So I know I haven't got a short between the -12 and anything else. Okay, so that's all the power headers in. That took a while. I'm sorry about that. It just does take a while. Let's see what it says next, because it's quite difficult to put in the voltage regulators with the capacitors, the big capacitors, because they kind of interfere with each other. So let's see what the build guide says. It says, okay, 2K, well, you've done them, power headers done them. Bolt LM, right, so it says do the heat sinks and the voltage regulators next. So that's fine. These are the small heat sinks that are the standard ones, if you like, in the build guide. If you wanted to run this at a higher ampage, i.e. take more amps out than 500 milliamps, you need to increase the size of these. Mr. Holt says in the instructions it's a balance between the transformer power supply amp that it can push in and then the heat sinks. So if the heat sinks are too small, it'll get hot and burn out. Now, to be fair, running it on a 1 amp wall wart transformer, I've had no issues at all with these heat sinks. And as I say, the bigger heat sinks, I haven't got one to show you, which I apologise for because they're in the case. The bigger heat sinks, they're not getting hot, so it's doing okay. So each of these regulators is rated at 1.5 volts. So I guess if you've got two of them, you're providing almost 3 amps of power, but you're not drawing 3 amps of power. You're drawing whatever's plugged into this. So it's what you draw that matters. And you can work that out on modular grid, right? So we're going to put these heat sinks on because these are the ones I've got. These are LM317s. So I'm going to leave the bag there so I know. And the reason for that is this one's an LM317 and this one is an LM337. A mistake that I have made in the past is I've done the wrong one in the wrong hole and then had to desolder it. And sadly, because these are quite chunky, they tend to pull the pads and then you have to make repairs. So rather than do that, we'll be a bit careful about where we stick it instead. That one's okay. So there we go. We've got a screwdriver, we've got the bolt. And then the other thing that's not in the build guide that I would recommend you get is some thermal paste. Nasty gooey stuff, gets everywhere, makes a right mess. So it's worth having something to wipe your fingers on before you start. So I'm just going to grab something. Got something to wipe my hands on. Got my thermal paste. Got my screw and my bolts. I'm kind of ready to kind of screw that all together. Obviously the thermal paste just helps the heat dissipate into the heatsink. Now when these sit in, they don't quite sit how you imagine. You can't put it that way up. Oh no, maybe you could actually. Yeah, you can with these. So we'll put it that way up, like that. So I'm going to put the thermal paste on the back of there. It'll come out in a gloop. I'm never sure how much you need. And use this like you use as if you were putting a processor on. I'm sure the other ones I've built, I've done it like that. Let's have a quick look at the picture. Let's have a quick look at the picture. How does... Oh, you can't see. Oh, you can't see it on the picture. Can't see which way up it is. On the other ones I've built, I've done them like that. So there's a gap. I think it'll be neater if I do it like that. But will it be as thermally efficient? I'm not absolutely sure. I don't know which would be the more thermally efficient. Would it be more thermally efficient to have a gap at the back of the thing and let air around it? I don't know. I'm just going to trim these off now, just to make my life easier to do the middle pin, and also I can check the solder around the others. So that's that, and then all we've got left now are the capacitors. It's important to remember that we get the capacitors the right way around. These are 47,000 UF, 4,700 UF I should say. These ones say 25 volt. Before I put them in, I'm just going to check that they should be 25 volt. Yeah, 25 volt, and there's 6 of them, a whole 6 of them. Positive leg, and you've got the negative marking on the capacitor. So we put the positive in, and negative there, and go. And this is it. This is the end of the build almost. Turn the soldering iron right down. So there we go. There we go. We've got a nice, fairly neat. I've got one box header that's lifted a little bit, but the rest of them are absolutely flat. It's only lifted slightly. It's annoying though, isn't it? Yeah, there we go. So what we need to do is just check for shorts. This is the inputs. If you're running it on a wall wart transformer, use AC1 and ground. So you have one wire going to there, one wire going to there. If you're using a center tap transformer, you'll have one of the leads there, one of the leads there, and the ground there. I'm not using a center tap transformer. I've told my sister's partner to go and get a wall wart. He will have to buy that because I need mine. And we've got no short between there and there at all. That's great. No short there. We should get a short there, and we should get a short there, but we haven't got it across the other ones. So that is safe to plug in, which is great news. So that is the Frequency Central Routemaster, all finished up. To make this work, all you need to do is wire this bit and mount it, and away you go. I'm going to do that off camera just because it's going to be a real fight, I think, to film it, and I'll show you it when I'm done. The other thing you need to do, once you've plugged it in and got power, you just need to adjust these screws here using your multimeter. You need to adjust the screws until you get minus 12 volt minus 12 volt there and plus 12 volt there, and you just have to turn the screw until you get that reading. That's it. You'll know if it's working properly when you plug it in because the LEDs will light up, which is always a nice moment when you see those. And there we go. That's the build bit over. We'll test it in a minute. The other bit you need is one of these. So this is an AC wall wart. They're called wall warts often. This one's 1.6. 1.6 amps. So 1,600 milliamps. A little bit over what's recommended. 230 to 240 volts, 50 kilohertz, and it's stepping down to 12 volts. So there we go. These cost about £10, give or take. And they are quite difficult to find because they're AC. As I mentioned before, these are AC. You cannot use an AC DC. You must use AC. And then I guess this is the moment of truth. Before I plug it in, I will just check continuity again because I don't really want it to go bang, and I have done some more soldering. So again, we'll go between the ground and the positive. We haven't got a short circuit, so that's a good sign, which means we can plug it in. And we should get some lights. We've got 2 lights, but not a third one. That's not great. So probably what's happened is I put the LED in the wrong way around. 9 times out of 10, that will be why. So I'll bet you that's what I've done. Put the LED in the wrong way around. And this is the LED that had that weird bit of plastic on it. I wonder whether the plastic stopped the solder joint. It's not the wrong way around. The other reason is it could be a damaged LED. So what I'll do, before I worry and panic, there's no smoke, there's no smell. So it's probably okay, and it's probably just the LED. So what we can do is we can find out if we've got continuity and all the rest of it, and if we've got the right voltage. So that'll be the best way to tell. So I'm going to put it into my voltmeter mode. I'm going to go to the ground, try not to short circuit anything. So that's my ground, and I'm going to go to the minus rail, and I've got minus 13.4, so minus 13.04. So that's really good, that's really close. On the positive rail, I've got nothing. That's not good. 5 volt rail is good. So the 5 volt rail LED that's not lining up. Oh no, it's the... Why have I got anything there? Now, of course, to get that flat on the board, I'm just going to have to bend the legs. Right, let's put the let's put the 1K resistor in that we forgot. See how easy it is to make a mistake. This is a bit of a worry. So it's not putting out anywhere near the voltage it should be. I'm sure it is the top rail. Ah, that's the positive rail there, dickhead. I've done this before and it's confused me before, because I always think that the positive rail is the top most line of pins, and it ain't. It ain't. That's where I keep going wrong. Do you know, I've ruined a whole power supply doing this because I thought that. So we're at 11.39, so we're close. 11.39. Let's go up just a half turn. So we should be somewhere near now. 1, 2, 3, 4. It's the 4th rail. Oh, so close. Let's go up a whole turn, I think. Let's go a whole turn. There we go. Whole turn. 1, 2, 3, 4. It's that rail. What an idiot. Oh, I'm so close. So we go a half turn now, I think, on the potentiometer. So there was me thinking, do you know what? I think I've got another power supply here sat next to me that I thought I'd blown up. And now I've realised my mistake. I don't think I have blown it up. I've just been putting the multimeter 1, 2, 3, 4 on the wrong rail. There we go. We're close enough. So we've got 12 volts positive there. 12 volts negative there. Just ever so, like 0.04 or 0.05 of a milliamp over. Perfect. And then we should have a 5 volt rail there. And we don't get to adjust that, but it's really close. Look at that, 5.021. So we're there. We've got a fully working power supply. If you bought the parts just, if you bought just the parts to build one, it would cost you 50 quid. But my advice is buy more of all these parts than you need, because it's so much cheaper and easier to order 40 of these and 60 of them or whatever it is than one by one. As we've mentioned, you can get the does the switch work? That's the other question. You can get the power headers if you're in the UK from Switch UK. Switch Electronics, they are. They've got them in stock. Yeah, the switch works. They're all going out. I'm going to pull the cable out. I'm just going to tidy up that last little bit of solder because it's just annoying me because it looks messy. So for less than £50, if you buy enough components, you've got a really good power supply. And they are a really good power supply. It's a linear power supply. Normally pay a lot more for a linear power supply. I mentioned Constant Lab. I've mentioned what's I mentioned? Constant Lab, Trogotronics. They're lovely power supplies. They're capable of delivering more power and doing it on one lead, as opposed to having to split power supplies into different power solutions. There's also Hamilton. Now Hamilton is probably the most expensive one, but it's also apparently the best in terms of no crosstalk and zero cross reference, but it's a very different system. Instead of using these boxed headers, it uses a rail tapped and bolted to make the power rails, which is beautiful and fantastic. But if you buy those rails, it's probably going to end up quite expensive. But they've got a very, very beautiful power solution, a linear power supply. There's a company called L-1. They make a nice power supply. Mungo Electronics make a nice one. Topper Brillo. So there's lots and lots of power solutions out there for bigger racks and things like that. And of course, there's things off the shelf. So Uzus Power is one of them, and there's probably IntelliGel have got a box with a case with power. So there are other options, but I'm broke, so I tend to build my power supply. So this is the bit that I think puts people off getting into Eurorack, having a power supply that works. But actually, the frequency central ones are great. They're relatively inexpensive. You can build them relatively cheaply. You just need your wall wart. Just remember it's an AC wall wart. Don't get an AC/DC wall wart, and you're away. You can't plug in your cables the wrong way around because you've got your boxed headers, which is great. You've got a 5-volt power supply if you need it. You've got a 12-volt positive, minus 12-volt, and you can see how accurate it is. It just sits there. It's linear. So it's a beautiful, beautiful power supply. I really, really like them. I think they are great bang for the buck. There are lots of other supplies out there. We mentioned a few of them. Dopefer, of course, with PSU3, which is probably what I'm going to do for my next case. I might go with the Dopefer PSU3. It's not a bad price. So the transformer bit is about £130 in the UK. So that's about $140, I guess, in the States. And then you can make passive buses. This is a powered bus, but you can make passive buses for about £15-20 maybe each. So that might be a different way to go. I'm going to have a look at that and consider it. Or I might stay with the good old frequency central Routemasters. This is now revision 3. So revision 3 is green. There you go. Revision 2, I think, is the other one I had, which is red. They're identical in every way. I've been trying to fix this one, which I've realised my mistake is not that there's anything wrong with it. My mistake is I've been putting the probes on the wrong pin for the plus 12 rail. So I've ruined a perfectly good PCB there for no reason. So there you go. That's it. Hope you enjoyed the video. If you want to give a like, please do. If you subscribe, even better. But I'm not asking anyone to do any of that rubbish, because every time you watch a YouTube video, somebody asks you to like and subscribe. I don't have a Patreon. I don't have a buy your coffee. I have a job. I have a normal job. So this isn't my job. It's just for fun. But I do hope you enjoyed the video. There is some new stuff coming next week. I'm going to go away from the build videos a little bit, partly because I've run out of stuff to build and I can't afford to buy any more. It's Christmas. But also I've got a bit of a plan for a series of videos on kind of how the modular works and the bits to do. But again, like I said, there are better videos from other people with higher production costs and values. Sorry, production values, people who do it properly, full-time, as a career. Go check them out. I've mentioned a few of them in this video, and in future videos I will be putting some links into those channels as well, because they're all really good people. Enjoy your modular, enjoy making noises. Even if you're not got a modular, enjoy your digital audio, enjoy creating songs, enjoy playing instruments, whatever it is. And peace be with you. Take care.